Good morning. My name is Purushotham, working as Assistant Professor in the Department of Electronics and Communication Engineering from MLR Institute of Technology. So, previous class I discussed about what is the frequency modulation, what is the mathematical expression for the representation of the frequency modulation. Today, what are the different modulators we are using for the generation of the FM. So, for that, I am discussing about what are the different types of modulators for FM generation. So first today lecture I am concentrating on generation of narrowband FM, generation of wideband FM. So FM we are classifying into two types. One is narrowband FM, second one is the wideband FM. Again wideband FM we are classifying into two types. So that is wideband FM can be generated by using direct method. Wideband FM can be generated by using the indirect method. So what is the narrowband FM? So here let us discuss about the modulators which generate narrowband FM and wideband FM wave. First let us discuss about the generation of the narrowband FM. So the narrowband FM is similar to the AM modulator. The expression what we are getting is similar to the AM. So how we are classifying? First of all we are classifying based on the value of beta. If the beta is nothing but modulation index in the FM. So beta can be defined as a del F by FM. Beta can be defined as del F by FM. So del F is nothing but frequency deviation. Beta is equal to del F by FM. FM is the maximum frequency component in the signal. Del F is the frequency deviation. So if beta is far less than 1, then we are calling it as a narrowband FM. If beta is far greater than 1, we are calling it as a wideband FM. This one is the wideband FM. This one is the narrowband FM. So if you are concentrating on the AM, there we are speaking about the modulation index. The maximum value of the modulation index is varying from 0 to 1. 0 to 1. If it is 100% modulation, we are taking it as a 1. If it is under modulation, we are taking less than 1. So now, the generation of the FM by using the narrowband frequency modulation. So we know the expression for the FM. So what is the expression? S of t is equal to, S of t is the modulated wave, AC cos 2 pi fct plus 2 pi kf integral m of t dt. In other way we can represent this expression as AC cos 2 pi fct AC cos 2 pi fct plus beta sin 2 pi fmt. Both the ways we can represent. So now we know if we want to expand this expression, it is in the form of cos A plus B. It is in the form of AC is the common cos A plus B. Cos A plus B is nothing but cos A cos B minus sin A sin B. So we are representing AC cos 2 pi fct, AC cos 2 pi fct, cos A, this one, cos B. Cos B is nothing but this is the A, this is the B. So cos 2 pi kf integral m of t dt minus cos A cos B minus sin A sin B. So the expansion of this is nothing but AC cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. So here cos A cos B minus sin A sin 2 pi fct sin B sin 2 pi kf integral of m of t dt. So for narrowband FM, we know that cos theta approximately equal to 1 and sin theta is also approximately equal to 1, where theta is very small. Theta is the very small. So cos below 1 value, when we are getting cos 0 is equal to 1. So finally we are approximating, this is the value we have taken, it is the theta approximately equal to 1. Why we are taking approximately equal to 1 means beta value. Beta is nothing but del f by fm. So here if we are taking the value, other way of expression is beta sine 2 pi fmt, or here also 2 pi kf integral m of t dt. Integral m of t dt is nothing but cos omega mt dt. Cos omega mt is nothing but cos 2 pi fmt dt. Integral of cos is nothing but sine 2 pi fm. If this expression what we are getting from this 2 pi kf integral of cos 2 pi fmt dt. So 2 pi kf integral of cos is nothing but sine 2 pi fmt divided by 2 pi fm. 2 pi cancel. 2 pi cancel. What is the value we are getting? Kf. And here amplitude is also there, am. So here we are getting am. Kf am by fm sine 2 pi fmt. So kf am by fm, this is nothing but del f by fm. This is nothing but beta value. So now, so here indirectly, so we are representing beta. So beta very small, sin theta approximately 1. So we are approximating to AC cos 2 pi fct. Next, what is the value you are taking here? Minus AC sin 2 pi kf integral m of t dt. Okay. So while we are approximating, the final expression what we are getting is nothing but, so this is the expression we are getting. So this is the expression we are getting from the narrowband FM modulator. So again, if you want to simplify this expression, so what I have written here, this is the expression what I have written. So the finally the expression what we are getting is AC cos 2 pi fct minus beta AC sin 2 pi sin fct. So what is the value you are getting finally? This is the value we are getting here. Beta AC sin 2 pi fmt sin 2 pi fct. The value what we are getting here. So now, so next to finally AC sin 2 pi fct, m of t is the sin 2 pi fmt. So again we are representing, this is the nothing but, again this is nothing but in the form of sin A sin B, which is nothing but 1 by 2 cos A minus B minus cos A plus B. Again we are representing this in the form of 1 by 2 cos A minus B minus cos A plus B. So the finally the block diagram what we are implementing for obtaining that expression is integrator and product modulator. For the product modulator we are applying AC cos 2 phi FCT with 90 degree phase shift, it becomes AC sin 2 phi FCT, and integrator output is nothing but integral of m of t dt. Then the product modulator multiplying two signals. Those two signals are nothing but AC sin 2 phi FCT here and multiply with 2 phi kf. This signal we are taking minus, and one more signal we are applying, that is nothing but AC cos 2 phi FCT. AC cos 2 phi FCT. So the S of t expression what we are getting is AC cos FCT plus beta sin 2 phi FMT. So this is the narrowband FM wave generation. Here the integrator is used to integrate the modulating signal m of t, and the carrier is phase shifted by the 90 degree, and finally AC sin 2 phi FCT we are getting, and the signal both signals are multiplied. Product modulator is nothing but is doing the operation, and output is again multiplied with 2 phi kf, and minus sign we are giving, and plus AC cos 2 phi FCT we are applying from here. Okay, so now the summer block two input, which are nothing but the two terms of narrowband FM equation, positive and negative sign, are assigned for the carrier signal, and the other terms at the input of the summer block. Finally the summer block produces the narrowband FM wave. Finally the summer block output we are taking is nothing but narrowband FM wave. So the narrowband FM wave is similar to the AM equation. Only the lower side band is reversed. So now here the phase shifted by the 90 degree here. So this is the way we are using for generation of the narrowband FM. Next, generation of the wideband FM. If beta is far greater than 1, we are using for the wideband FM. Again it is classified into two types. First one is wideband FM generation by using direct method, wideband FM generation by using the indirect method. So in the direct method, it is nothing but definition of the frequency modulation. Direct method generation is nothing but which is similar to the definition of the frequency modulation. What is the definition of the frequency modulation? The frequency of the carrier is varying according to the information signal or modulating signal or baseband signal. That we are calling it as a frequency modulation. So here, what is the method we are using? Voltage controlled oscillator is used to generate the wideband FM, and direct method voltage controlled oscillator we are using. So the voltage controlled oscillator is producing the output signal whose frequency is proportional to the input signal voltage. This is the similar to the definition of the FM. the frequency of the carrier is varying according to the input signal amplitude. That is nothing but according to the original information signal, carrier frequency is varying. So here, which one is performing that action? Voltage controlled oscillator is performing that action. So modulating signal input we are applying, voltage controlled oscillator is varying, and it is producing the wideband FM wave. So this is the directive method. Next, that is nothing but the mathematically we are representing Fi is directly proportional to the M of t. Mod Fi is the instantaneous frequency is directly proportional to the amplitude of the modulating signal. So Fi is nothing but Fc plus Kf M of t, where Fi is the instantaneous frequency of the wideband FM wave. Okay, so this is the direct definition. Indirectly it is reflecting as the definition of the frequency modulation. So another method is nothing but indirect method. Indirect method, other name is nothing but Armstrong method of generating the wideband FM. So here this method is called indirect method because we are generating the wideband FM indirectly. We are not generating directly, we are generating the wideband FM indirectly. First we are generating the narrowband FM, then output we are applying to the frequency multiplier. The frequency multiplier is the non-linear device, and finally what is the output we are getting? Wideband FM we are getting. So the block diagram of the generating the wideband FM wave is this one. First modulating signal we are applying and carrier signal we are applying. So narrowband FM modulator, the output of the narrowband FM modulator is applied to the frequency multiplier. So the output of the frequency multiplier is nothing but wideband FM wave. So this block diagram contains mainly two stages. First stage is narrowband FM generation using narrowband FM modulator. Second is frequency multiplication. So in order to get the required modulation index, so generally narrowband FM, the modulation index is beta less than 1. So but wideband FM modulation index is beta greater than 1. So beta less than 1 we have to convert into beta greater than 1. So in order to get the required modulation index, that is greater than 1, FM wave choose the frequency multiplier values properly. The frequency multiplication value we have to select properly. Then we will get the beta value greater than 1. The frequency multiplier is a non-linear device which produce an output signal whose frequency is n times the input signal frequency. The frequency of the output is n times the frequency of the input, where n is the multiplication factor. N is the multiplication factor. If narrowband FM wave whose modulation index is beta less than 1 is applied as the input to the frequency multiplier, then the frequency multiplier what it is doing? It is converting and it is producing the output signal whose modulation index is greater than 1. So that is n times beta, and frequency is also n times the frequency of the wideband FM wave. N times the frequency of the wideband FM wave. Frequency multiplier, to get the desired FM wave, it is multiplying the frequency. Wait, what is the reference frequency it is taken? Input signal frequency only it is taken, and it is multiplying such a way that the output what we are getting, beta is greater than 1 we are getting. So beta is greater than 1 if we are getting, automatically it is satisfying the condition of wideband FM. So then wideband FM is generated. So today what I have discussed is what are the FM modulators and what are the different types of FM modulator. FM modulator which is used to generate the frequency modulated signal. So frequency modulated signal we have to generate means two types of FM modulators we are using. Those modulators are classified based on the beta value. If beta is less than 1, we are calling it as a narrowband FM, which is similar to the AM modulator only. And beta greater than 1, we are classifying it as a wideband FM. Wideband FM can be generated by using the indirect method and a direct method. The direct method of generating the wideband FM is nothing but by using the voltage controlled oscillator, which is working as the definition of the frequency modulation. The definition of the frequency modulation is nothing but the frequency of the carrier is varying according to the instantaneous values of the modulating signal. Instantaneous values of what parameter we are taking? Amplitude of the modulating signal we are taking. Okay, according to the amplitude of the modulating signal, the frequency of the carrier is varying, then we are calling it as the frequency modulation. In the voltage controlled oscillator also, the voltage, output voltage is proportional to the input voltage. Okay, so then we are generating the narrowband FM, wideband FM by using the direct method of the frequency modulation method. We are generating the wideband FM by using the direct method, by using the voltage controlled oscillator. Next, indirect method is nothing but Armstrong method. Other name for indirect method is Armstrong method, which is generated by using the frequency multiplication. That is nothing but, first we are generating the narrowband FM. The narrowband FM output is applied to the frequency multiplier. So frequency multiplier, what it is doing, it is multiplying the frequency, base frequency it is taking, reference frequency, that is modulating signal frequency it is taking, and it is multiplying such a way that we are getting the modulation index or beta value greater than 1. So n times multiplying the original frequency and we are getting the beta value greater than 1. Once we are getting the beta value greater than 1, automatically we will get wideband FM signal. So next class we will discuss about the demodulation of the FM.